accepted, challenge accepted. Reality is always challenge accepted. Challenge accepted, challenge accepted. Reality is always challenge accepted.
And now, time to talk about something we all rely on every day, automation.
Specifically, how to take those pipelines in the cloud and make them run smoother than freshly brewed coffee.
Our next speaker is a software architect at IBM, leading teams in building CI/CD frameworks, container pipelines, and cloud-native workflows.
Serafim Karparov is passionate about Java, GitHub Actions, Docker, Kubernetes, and when he's not debugging pipelines, he's been the best friend of his 4-year-old son, with cold beer in hand. Serafim, that is not his 4-year-old son.
Today, Sefo is going to show us how to automate smarter with one of the most popular workflows engines out there, GitHub Actions.
Please welcome me with big round of applause, Serafim Karparov!
I think I'm audible now. Okay. So hi everyone again. My name is Serafim. I work, as you heard, for the big bull, IBM. And in our department at IBM, we use GitHub Actions a lot. So today we'll understand what these GitHub Actions actually are and how to use them smarter. And we'll leave some space for you to dive a bit deeper inside the more, let's say, advanced stuff. And I want to start with some apologies about the title. So initially it was a reference to a famous movie, but unfortunately I kind of influenced the weather outside. But for the people, our guests coming from Netherlands, they feel almost like home. So again, sorry for the Bulgarian community here. So what are actually the GitHub Actions? Given the time of the day, some people might think that these are the actions that you perform in GitHub during your lunchtime, or you perform other things. Other, like people probably in San Francisco, may think that these are the actions that they do during their Uber driving. So it's a recent example of a brave guy that was doing his work during probably workday, and he was brave enough to let's say, not face his manager in his own Uber drive. So let's see what they are actually about. These are, let's say, cloud-native solutions for automation, and they are integrated heavily within the GitHub ecosystem. You can customize the workflows with pre-built actions, or you can extend these actions or these workflows with your own implementation. They are YAML-based. Yeah, YAML is emerging even more nowadays. And the use cases are from building, notifications, deployment, basically everything that you can think of that could be automated. So for an instance, the last action that I wrote recently was a one for extracting some readmes from Jira, uploading them to our proprietary service and making them available in one of our AI assistants. So yeah, sky's the limit here, as you can notice. What are the key benefits? Well, their tight integration with the repositories and the whole GitHub ecosystem is probably the most important one. You have all the events that could happen in a repository. You have the secure store. You have basically the issues, what could be raised inside GitHub, and you can tightly couple your workflows or GitHub Actions and respectively GitHub workflows with them. There is a broad range of pre-built actions that are either developed by GitHub themselves or by a community or even GitHub partners. And the next thing, easy parallelization and scalability options. We will see how to achieve that. It's almost like a piece of cake to scale your pipeline, scale your workflow, and also consider what is the cost about it. So GitHub provides a really cost-effective tiers. One of them is free, so you can start using GitHub Actions today directly. And yeah, that obviously applies to smaller teams. If you are a big enterprise, you may go to some enterprise plans and use them for your daily activities. So how many people actually here use Jenkins today at their job? Okay, and half of the room, let's say. And how many people use GitHub? Okay, so we have quite a diversity here. Okay, so I've decided to do a comparison with Jenkins because it seems to be the CI tool that is used the most. Actually, my first job when I started my career more than 15 years ago was to write Jenkins plugins. It was all Java extension points. You have to build the things. It was actually not called Jenkins at that time. It was Hudson before Jenkins was forked. But it was, let's say, a challenging task for a student trainee. And yeah, Jenkins is still there today. And yeah, I decided to just make a few obvious things that we can compare with the GitHub Actions and the GitHub Workflows capabilities. So what's the setup for Jenkins? Yeah, it requires somebody to set it up. It could be easy, but you have to maintain it. With GitHub Actions and GitHub Workflows, you just have them out of the box. If you have a GitHub repository and your administrator has, if you're an enterprise, has approved the usage of Actions, you can create your first workflow today. Doesn't need to set up a separate server and maintain it. The ease of use, yeah, for Jenkins, we can say that complex pipelines could be defined with the enhancements that we had in the recent years. Before that, everything was about freestyle jobs, clicking here and there, while with GitHub Actions, it's just YAML, and it feels more natural for a DevOps person to implement it. Cost, well, there is a pay-as-you-go, which is obviously the choice for enterprises, but for small teams and for your personal usage, yeah, you can use it for free. For Jenkins, you have the ability to run it for free, but as we mentioned, it requires the infrastructure. As long as the community, GitHub has a thing called GitHub Marketplace for actions. You can browse any actions that are already developed, as we mentioned, either by GitHub partners, or even by somebody here in the room. So it's extremely easy to implement an action, and we will see actually today how this could be done. We will implement our first action. While in Jenkins, there's a large plugin ecosystem, again, kind of a similar thing. Extensibility, Jenkins, it's mostly Java. And yeah, as I mentioned in the beginning of my career, I have to deal with that. While now with GitHub Actions, you have several options. Actually, I could say sky's the limit again. So you can use the so-called composite actions, which are actually shell actions. And you can write things in Bash or reuse another actions and put them as children of your own. And let's say compose them like a Lego. You can use JavaScript using the node type actions, or you can use Docker, which actually makes it possible to use any other language. So if you are a Python developer or I don't know, C# developer, you can compose your logic inside a container image, or even, I believe, just a Docker file. GitHub will make the build and produce that image that performs the business logic, and you can use, in general, any programming language as far as you use Docker. So, yeah, that was kind of the theory and the basic stuff. We will show some code and how a GitHub workflow actually looks like. As we can see, the first thing is the workflow name. Yeah, we have to name them. In our case, it's called weather workflow, and we see that it will do some things about weather. There is section which begins with on, where you specify when this workflow will be triggered. Similar to other CI tools, there are possibilities in general to trigger this workflow using some events or manually, like using the dispatch. In dispatch, workflow dispatch, you can also specify inputs, which the user who triggers the actual run can specify. You can have defaults, all the natural things that you would expect from a CI server. As long as the events, basically you have many options. Most of the used are triggering the workflow during pull request, to compile the code, test the code, do some linting, so on and so forth. And once you have a push, for example, in the main branch. Logically, the next thing is to define what this workflow will actually do. That happens via the so-called jobs. These are independent pieces that you can chain. They could be completely independent, or you can say this job needs the other, and they can be chained and be made sequential. You can also combine everything. So a job has a name and ID, which is completely user-defined. In our case, it's called build. And the next thing that one has to do is to define where this job will be run. In our case, this is Ubuntu latest. It's a label, so it's not a single VM or a container or something else. It combines a set of, let's say, runners, a set of workers where, your activities will be run. Actually, the cool thing with Ubuntu latest, I believe it's available out of the box in public repositories, is that it's already there for you. So if you have a GitHub repository, define such a workflow and define this Ubuntu latest label, the actual runner will be created for you. You don't have to register your own VM. You can use it. GitHub makes it available for you, and it actually has a lot of tools pre-set up, like kubectl, Helm, CLI, and many others. So in general, if you are an enterprise or you want to register something specific, you can bring your own VM or a cloud runner or even your own machine. It's a piece of cake again. So GitHub gives you the instructions, you supply a label, and then your VM could become a runner. We will see, by the way, a note for how these things could be scaled with runners in one of the next slides. The jobs are actually composed of steps. And the steps here, we have the, not a limitation, but the standard that they are always sequential. So you can run jobs in parallel, but the steps should be always sequential. In our case, we see that we have just 2 steps, but they should be illustrative enough to demonstrate the, let's say, 2 flavors. The first one is an action called checkout. It's obvious what it does. It checkouts our code, for in this case, from the same repository where the workflow resides. But you can supply some of the inputs, check out another repository, different branch, whether to check out submodules or not. So many options that are available in the actions documentation. The key here is that this action actually comes from the GitHub marketplace. So it's created for you, available out of the box by GitHub, and you can use it freely. The next one is the so-called custom action. So, or custom step actually in this case. It's just running a shell command. In our case, winter is coming. It's not exactly winter if you go, but if you go in the mall, you'll see that there are already Christmas decorations. So it's almost here if you ask somebody from the mall shops. And it's completely written by you. You can define any shell command here. But now let's say that this custom step is something that's really useful for somebody. Probably somebody in our organization, probably really somebody in the whole GitHub community, and we have to make it reusable. How to make it? Well, we will write our own composite action. So yes, it's really straightforward this to be done. And as you can see, we are defining a single YAML file, which is always designed by contract. It's called action YAML, and it resides in some repository. In our case, it's called organization names / weather action. So that's important. The repository name and organization will be the way how people from your organization or the GitHub community will actually use it. So it has its own metadata, which are usually the name, the description that the users can browse, and of course the inputs. So you can parameterize your composite actions and define various number of inputs. In our case, it's just the season, and it has a default value, which is winter, and it's required by default. So if we didn't have the default value and somebody uses the action without specifying the season, then yeah, GitHub will be smart enough to tell that it will fail and you will have to supply it. Then it's actually the set of steps that our composite action contains. In our case, it's a set of, again, shell steps, if we can say it that way. But as I mentioned in the beginning, it could be also completely different GitHub actions that either you wrote or somebody else wrote, or yeah, GitHub provides out of the box. So yeah, in our case, it's just the shell actions. Where on line 10 we see that there is a using keyword here in the DSL and it's composite. It actually defines the type of the custom action that you use. Remember in the beginning we said that one can use Docker or Node. So yeah, this is basically how you define the type. How to use it? Well, let's go back to our previous example. We still keep the checkout action, which was and is available out of the box in GitHub. But now instead of defining run instruction, run DSL that will run our custom logic, in this case, we just define the usage of our completely new GitHub action that we just wrote. How to do that? Well, we define a name. And remember, we said that the repository name and the organization is quite important. So in the uses keyword, we define exactly that. And of course, use the required version that the action has. So actions evolve, so they use semantic versioning, and in general, basically, these are tags or branches that the owner of the repository has created before that. How to parameterize? Well, obviously, using the with keyword and defining our custom input. In this case, instead of the default winter, we specify the spring, and at the end of the execution, we'll see spring is coming instead of winter is coming, and of course, the new thing that we added in addition, which is brace yourself, the additional step in our composite action. Security best practices. After all, actions are again code, and or they are libraries or something that is reused from somebody if they are not written by us. And we should be really cautious about security here too. And there are several things that everybody should have in mind and do whenever a third-party action is being involved inside your workflows. Always review and scan the source code of these actions, especially as I mentioned, if they are third-party. Check for the verified actions batch. So it means that the creator is a partner of GitHub, and it obviously kind of means like that it's a verified action, and you can be like more open for using it. Pin action versions, what does it mean? In our example, we show that we are using the v1.0.0 version, the semantic versioning, and we are not using, for example, directly the main branch. We don't want to always consume the latest available thing out of the box. We may want to review it. There might be some breaking changes, and also there might be the case that somebody intentionally injected something new inside this branch or tag. My own preference and the team's preference where I'm working for is to use directly hashtags instead of tags, the hash of the commit that corresponds to the particular version that we are using. So this way you are better on the security side. And yeah, obvious thing, avoid sharing sensitive data with untrusted actions. You don't want to put your username and password or kube config file directly to an action that is considered untrusted, and people can steal your secure data. If we get a bit aside of the actual actions that are used, they are and look at, as a whole on the GitHub workflow. always there is an out-of-the-box secret store called GitHub Secret Store. You can find it on the settings page, and you can. It's actually looks pretty simple, but you can basically handle most of the use cases that you need for your workflows. You can define a key value pair where the key is your actual name of the secret, and then define user-defined secret. It could be just a username API token, or could be the whole kubeconfig file that you use for connection to Kubernetes. Securing environments is a good practice when you have a large team and there is a responsibility just for several of the team members to deploy to production, for example. You don't want everyone to be able to approve rolling out your changes. If you have the whole pipeline deployment from source to the final production deployment, you don't want sometimes to give the possibility that to happen completely out of the box. There is a way to define environments inside GitHub and protect these environments using deployment protection rules. What does it mean? You can list, I believe, up to 6 people that can have to manually go and click approve on the last step that will make the final deployment. They will receive an email, and only they will be authorized to do certain things. Of course, you can define also secrets that are bound exactly to this environment. So if you use an action or a part of your workflow touches such a secret, it should be pointed out that that piece of code has to deal with this environment, and somebody has to manually click the approve button of the execution. By default, GitHub injects a thing called GitHub token, which usually has access to basically doing almost everything inside your repository. You can control that too. So in your workflow, you can define what are the privileges of the GitHub token and reduce them. For example, just reading the data. You can use also other tokens for other repositories, but be strict and in general use the least privilege for this type of tokens. Well, we saw the security perspective. Let's now try to scale the things. So what we have here, we have the same workflow that we saw before that, but yeah, in this case, we have something new, which is called strategy. So in this strategy, we say that the strategy here is matrix. What does it mean? Well, it means that GitHub will do a matrix execution of all these additional parameters or the DSA options that are defined under the matrix keyword. So in our case, we have the 4 seasons, spring, summer, autumn, winter, and we also have different runners. For example, we want to execute this action on various environments, and yeah, you can already probably think that and see that this workflow will be executed more than once. Actually, it will be executed 8 times, to multiply it by 4, and we almost didn't do any change. We just reused the matrix parameters in the runs option. In our case, oops, in the runs option, just accessing the matrix contracts with the OS keyword, and the similar thing is also in place for the season input in our custom action. So after executing this, this is the bounding that I was talking about. After executing this, we will see that an execution of the build job will not be just one. As I mentioned, we will see 8 different executions doing the combinations of all the parameters that we saw. So yeah, easy way to scale your action and actually your workflow and test on various environments or with different parameters. Let's explore some efficiency tips. GitHub provides out of the box an action which is called cache. Action/cache. It can speed up a lot of installations that you are doing. For an instance, if you're using Gradle, we know there is a Gradle cache, Gradle wrapper, and sometimes you want to or always you want to speed the things up and reuse what was downloaded from a previous execution. Well, the GitHub Actions cache is exactly what you use in this case. Yeah, it could be reused with npm, walk files. Again, you have it out of the box with the action. There is a nice way to scale also your runners or the workers that are available inside your GitHub workflow. How to do that? Again, a project that I believe is backed by GitHub itself called Actions Runners Controller. It's a Kubernetes operator. If you have a Kubernetes or better OpenShift, yeah, you can use this Actions Runners Controller and easily scale your own self-hosted runners. So self-hosted runners is basically runners that you own and dynamically create runners which are essentially ephemeral. So there is some job to be done. They are created, the job is done, and they are destroyed. So this is basically saving you a lot of infrastructure. And you can imagine that this is completely based on containers. You can also switch your own base image that is used inside this Actions Runners Controller and have all the necessary tools that you need during your workflow. So yeah, that was a brief introduction to GitHub Actions. Feel free to explore it. It's very nice. As I mentioned in the beginning, you can do it right now. And yeah, it basically does not require any pay-as-you-go account. You have it directly available in your GitHub repository. And yeah, today it's cloudy. It was cloudy with a chance of CI/CD, but we also have a chance of winning a World Cup. So as the organizers mentioned, we will have the ability to watch the game during the lunchtime. And I think that was from me. I'm open for questions.
Thank you very much, Sefo. Any questions?
Nope.
There are lots of questions, like 4 of them. The game starts at 1:30, so you can stay here asking questions.
Hello?
Yes, hello.
You already touched on this a little bit, but essentially the actions are open source repos maintained by people.
Exactly.
And you said we should always look for the verified badge, right?
Yes.
So my team handles payments, so it's quite sensitive. If somebody leaks our stuff because they were malicious, can we then sue GitHub because they had the verified badge and essentially guarantee this was a vetted repo? Because I'm not going to sit and read the source code myself, probably.
Yeah, it's a legal question, but I think it's possible. So what I advise, actually, especially if you have a GitHub Enterprise server, your own hosted GitHub Enterprise instance, is to clone the actions, scan them, and reuse them from your own instance, not directly from GitHub. This way, you will guarantee the safety of whatever you're doing.
Thank you.
Second question.
The next question?
Yes, I have a question over here as well. Hi, my name is Kian. My question was around runners.
Okay.
So I know you can have local runners. Can you also have cloud-hosted runners where you have run and some HTTP endpoint?
So if I understood the question, you are asking whether you can specify an HTTP endpoint that represents a runner. Is that the case?
Yes, so I don't want it on GitHub. I want it on Azure or on the...
Absolutely. So it's not an HTTP endpoint. You have to just register it. If you have a VM or a container in Azure somewhere, you have to run, I don't know, it was around 2 shell commands that contain a token against this runner, and it will be able to self-register against the repository. You will see it as a labeled runner there, and yeah, you can use any cloud provider or any machine or whatever you want. It doesn't have to be owned by GitHub. Just GitHub provides some out of the box.
Thank you.
Yeah.
Thank you.
Thank
win
you.
a t-shirt. And there was one more question, just like there, huh? Okay.
Hello.
Hello.
Have you tried, or do you know how hard it is to add AI agent or something like this in those steps?
Yeah. So Yeah, I noticed that I don't have a single slide with AI on my presentation. AI agent, I haven't tried to add an agent, but it should not be a problem. I can tell you that AI helped me in another direction to write my recent GitHub action, and having this, let's say, openness for the GitHub community makes AI really knowledgeable about how to use all that ecosystem, and it's a piece of cake for an agent or an assistant to write your workflow or to use the outputs of your workflow and react based on these outputs. But personally, I haven't tried like an agentic implementation or usage of the workflows.
Thank you.
Sure.
Thank you.
Thank you very much. The next question, you will have to ask them in the speaker's corner where you can meet Serafim. Let's now send him off the stage with a quick round of applause. Serafim Karparov!
Thank you. Благодаря.